Assalamu alaikum warahmatullahi wabarakatuh. Subject Computer Science for 11th Standard A section. Last class we completed chapter 7. Now we are going to start a new chapter, chapter number 8, Iteration and Recursion. In this session we are going to cover the following topics: iteration and recursion, invariance, loop invariance, invariance example, and recursion. Let's start our class. First topic, iteration and recursion. What is iteration? Of course, we know in algorithmic techniques there was a special technique called iteration, which is used to repeat the group of statement or a single statement more than one time depending upon the condition. However, there is also a property of the variable which remains unchanged by the execution of the loop body. That means a loop body is a group of executable statements which are repeatedly executed for more than one times. But each and every time whenever the loop body executed, some of the variables property remains unchanged. This unchanging property of variable is called loop invariant. So this is the important concept of iteration. Without a loop invariant, we cannot construct the loop. So loop invariant is the basic element for any loop or iteration. Consider the loop invariant is the key to construct and to reason about the iteration algorithm. So for using iteration algorithmic technique, we should know what is invariant. So I repeat, invariant is the property of any variable which unchanged, which remains constant, which remains unchanged by the execution of the loop statements. Next one is recursion. Recursion is similar to iteration, but it is another technique closely related to iteration but more powerful. We can solve many big problems through recursion by solving the same problem with a part of the input and constructing a solution to the original problem from the solution to the partial input. This is the basic concept of recursion. It means, which we know already in the decomposition, we learned that we're dividing a big problem into smaller problems and try to find the small solution for the small problems, and after completing the small problems and find outing the small solutions for smaller problems, we assemble all the solutions, small solutions, together to get the final big solution for that big problem. In the same way, recursion also divide a big problem into smaller sections and try to give the smallest input or partial input of that loop and get the whole original solution for that problem. So these are the two important things which we are going to learn in this chapter. One is invariant or loop invariant, another one is recursion. Next topic is invariant. So we can understand the invariant with many examples. So the first example is, suppose we have assigned a two variables values as 2015. The two variable name is UV. We can annotate before and after the assignment. What is the invariant here? So here in this example, consider two variables UV which values are 20 and 15 before the loop starts, and after some execution, some doing some processing, that variable's property remain constant. That variable property is known as invariant. See here, before the execution, value of the UV is 2015, and this is the execution statement which we want to execute. So U plus V and V minus V. After assigning, we observe that U plus V, 20 plus 15 is 35, and after execution of this statement, U plus V is 35. So because here in this statement, value of the U is incremented by 5 and value of the V is decremented by 5. Because of that, before the execution of statement, after the execution of the statement, u plus v remains same, that is 35. So before execution, value of the u is 20, value of the v is 15. So 20 plus 15, 35. After executing the statement, value of the u is 25, value of the v is 10. So 25 plus 10, again 35. So here we can say u plus v is an invariant. It is 35 before and after. So this is the simple example for identifying the understanding the concept of invariant. So invariant is the property of any variable which remain unchanged. So next example is, consider the two variables, namely p and c. The value of the p and c before the execution of the statement is 10, 9, and after the execution of the statement, value of the p and c is 11, 9, 11, 10. Because in this statement we increment both values by 1. So p is equal to p plus 1, c is equal to c plus 1. Now what is the invariant here? Here p minus c is the invariant. How? See, before executing this statement, p minus c, that is value before executing our of p, p plus c, p plus 1 and c plus 1, value of the p and c is 10. So 10 minus 9 is 1. After executing this statement, so value of the p is incremented by 11 and value of the c is incremented by 10. But here also, when we subtract these two numbers, two variables, p minus c remains 1. So here p minus c is equal to 1 is an invariant, because before and after executing this statement, the value remains constant in this expression, that is p minus c. That's why we called it as an invariant. So next thing which we are going to discuss is the invariant with some examples. See, show that p minus c is an invariant of the assignment. Let's say it. So there was no value, but we are theoretically deriving deriving this expression using the mathematical rules. So p comma c is p plus 1 and c plus 1. This is the execution statement. Let consider p of p minus p comma c is equal to p minus c. Then what will happen? See, value of the p and c is incremented by 1 before execution. After execution, p and c is considered as p minus c. So it is converted as p minus c. Again, when we try to apply this concept, that is p minus c, into the into the value of pc. So value of the p is p plus 1, value of the c is c plus 1. So this p minus p can be written as p plus 1 minus c plus 1. So again we come into the same concept, p minus c. So from this expression we can show that p minus c is an invariant. This is the simple mathematical theorem by which we try to give some uh, proven statements for proving p minus c is an invariant. So next one is, consider two variables, namely m and n, under the assignment. So value of the m and n is m plus 3 and n minus 1. Is the expression m plus 3n is an invariant? This is the question. So what we want to do, so consider again p of m comma n is equal to m plus 3n. So what is the value of p m comma n? So p m comma n value is m plus 1 minus comma n minus 1. So here we can also write m comma 1 as a m plus 3 1. That's why we change the value, and when we change the value and try to use that values, so value of the m is m, and the value of the m is m plus 3 and value of the n is n minus 1, which we write here. So using this statement, so value of the m is m plus 1, value of the n is n minus 1, which we applied here. So 3 of n minus 1. After multiplying the elements, we find out that m plus 3 n minus 3. So after deriving this statement, so plus 3 minus 3 is removed and m plus 3n comes out. So from this statement we prove that m plus 3n is an invariant for the statement. So next one is the loop invariant. What is the loop invariant? In a loop, if L is an invariant of the loop body B, then L is known as the loop invariant. So the loop invariant is true before the loop body and after the loop body and each time whenever the iteration executed. So this is the basic condition for any loop invariant. So loop invariant should be true before the execution of the loop, after the execution of the loop and each and every iteration of the loop. Since L is true at the start of the first iteration, L is true when the loop ends, also true, and thus if L is a loop invariant, then it is true at four important points in the algorithm as annotated before. Here, one at the start of the loop, at the start of each iteration, at the end of each iteration, at the end of the loop. In this 4 point, L should be true. So here you can see the true flow chart. So here becomes input, we accept input here, and here the loop condition statements executed. So whenever the loop condition executed statement, the value of the L is 1, that is true, then it goes to execute the body of the loop, that is B. At that time iteration start, that time also in the second state the iteration should be true. At the end of the loop iteration, that time there is the third point, here also L should be true, and when iteration goes on execute for more than one time, for 2 and 3 point L value should be true. When the loop ends at that time also, that is the fourth point, should L value should be true. So these are the four important places where any invariant loop invariant should be true. So next one is invariance example. Consider we are finding out the power of two numbers. 10 comma 4 is 10,000, power of 5 comma 3 is 125. So algorithm for any two finding or find outing the any two numbers power, as example here power a comma n, it means a power of n computes, and by multiplying a cumulative n times, we are multiplying the number a for n times and accumulating all the product results. This is what we do. So for writing the algorithm, this is the specification of that algorithm. Name of the algorithm is power of a comma n, and input is n is a positive, it should be positive integer, and the relationship between input output is p is equal to a power of n. P is equal to a power of n. It is not an, it is a power of n. So what we'll do is, at the beginning of the loop value of the p is 1 and the value of the I is 0. Here we check value of the I should not equal to n. So here I is the variable, that is iteration variable, which controls the iteration. Each and every time whenever the loop execute, value of a and value of the I is power to the value a and find out the product, and which product is stored in the variable b. P, which is going to see here. So with at the iteration 0, that is when loop starts for first time, value of the p is 1, value of the I is 0. So a power of I is 2 power of 0 is 1. So when first iteration execute, value of the p is 2 and value of the I is 1. So 2 into 1, so 2. So 2 power of 1, 2. At the time a second iteration, value of the p is 2 and value of the I is 2, 2 power of 2 is 4. So in this way we find all the power values and finally we get the output of 2 power of 5, that is 32, and which we store in the variable p. In this situation all the variables are executed and updated each and every time. So this is how we calculate the invariant. Next, the another very popular example which we already discussed, that chocolate bar cutting. So consider there are two variables for chocolate bar cutting. One is P, another one is C. P refers to number of pieces, C refers to number of cuts. So before executing the process, each and every time whenever we cut, the value of the P is incremented by 1 and value of the C is incremented by 1. So this is the execution statement. We start one piece and 0 cuts. So value of the P is 1 because the whole bar chocolate is considered as a single piece and there was no cut, that's why C is equal to 0. Let n be the number of individual squares which we want required. So we execute this process, that is P plus 1 C plus 1, that is cutting process, till we reach the number n. Value of the pieces is equal to number of n. That is how many pieces we require, that is mentioned in the variable n. Consider the process ends when value of the p is equal to n. Each and at the beginning of the loop, value of the p and c is 1 0, and whenever the loop start, the value of the p is incremented by 1 and value of the c is incremented by 1. Each and every time at this position, p minus c is k. That is, k is the constant number which remain constant in 4 points. This is called the loop invariant basic condition. So p minus c is equal to k, p minus c is equal to k, and p minus c is equal to k, p minus c is equal to k. This is the four statement where these k values remains constant. Consider here. So 1 minus 0 is 1. So value of the k is 1. When loop execute for the first time and cuts the value, now here value of the p is 1, value of the c is 0. So again in the second point at the first iteration, value of the k is 1. And at the end of the position, so value of the p is incremented by 1 and value of the c is incremented by 1. So p becomes 2, c becomes 1. When we implement this statement p minus c, again we get 1, that because value of the p is 2, value of the c is 1, 2 minus 1 is 1. So in the third point also, the k value of the k is 1. So when iteration continues for more than one times, each and every iteration time, in the both this point at the second and third point, value of the k remains constant, and at the end of the loop, when iteration condition is false, then when loop terminates, at that time also value of the p is p minus c is equal to k. For example, when we loop ends when this condition is false. So when value of the for example, if we want 5 numbers of square chocolates, then value of the n is 5. So when value of the p reaches at the point of 5, so at that time, so value of the p is 6 and value of the n is 5. So at that point, in that time, value of the p is 6, value of the n is 5. So condition is false. When loop ends here, so value of the c becomes 5. So 6 minus 5 is 1. This is how we calculate the chocolate bar cutting process. In these 4 points, value k remains constant, that is k is equal to 1. That's why k is equal to 1 and the loop invariant is p minus c is equal to 1. This is the two in loop invariants, that is two. The loop invariant p minus c is equal to k is true at the start of the loop. Moreover, at the start of the loop, p minus c is equal to 1. Therefore, k is equal to 1 and the loop invariant is p minus c is equal to 1 for 4 at the 4 points. So 1 at the start of the loop, second start of the iteration, end of the iteration, and fourth one is end of the loop. Next one is the another example for identifying how we can calculate the loop invariant. So suppose consider there was a 6 trees and 6 sparrows are sitting on these trees, one sparrow on each tree. If a sparrow flies from one tree to another, then at the same time another sparrow flies from its tree to some other tree with the same distance away but in the opposite direction, is it possible for all sparrows to gather on one time? Consider there was a 6 trees, namely I, J, K, L, M, N, and there was 6 sparrows are sitting. When any sparrow flies in one direction, consider it was in uh, clock direction, and another sparrow flies from that tree to in anti-clock direction. So in the this is the way how they travel from one tree to another tree. But here we want to calculate what is the invariant here. When we consider this invariant, we cannot able to identify the invariant because it is not possible to calculate the invariant because there was no constant element. So when the loop ends, the loop invariant has the same value. However, when the loop ends, if all the sparrows were on the same tree, it is not possible because whenever one sparrow flies from one tree, that particular sparrows when reaches that tree, that J tree sparrows also flies from that same location and travel to another. So consider 6 trees. So I am going to use MS Paint for easy explanation. So consider six trees, namely I, J, K. So here I am trying to write this one is I, this one is 2, this one is 3, this one is 4, this one is 5, and this one is 6. So consider a sparrow travels from here in clock direction from here to from first tree to second tree. In the same way, the second tree sparrow travels from opposite direction and travel to this first tree. So whenever this process execute in any direction, you can see there is only one sparrow in a tree, and there was no chance to gather all six sparrows in one tree, either in tree number 1, tree number 2, or any number of trees. So this is the basic question, basic problem. That's why we cannot execute this algorithm, this statement in form of loop, and without forming invariant we cannot form a loop statement for this. This is an invalid loop statement. Next one is consider the chameleons of Chromeland where two colored chameleons meet each other, then their colors are converted into third color. That is, when red and green chameleons meet, then they converted into blue. Otherwise, either green or blue meet together, then it converted into red color. So consider there was a 13 red color, 15 green color, and 17 blue color chameleons are there. So how we can create a algorithm for that meeting and achieve all the chameleons converted into same color. Before that, we want to analyze these inputs and their output relationship. So here we write the algorithm name as changes RGB. So when if you consider red and green chameleons meet to each other and converted into blue, then value of the R is reduced by 1, value of the green is reduced by 1, and they are incremented, blue value is incremented by 2. So otherwise there is another chance, either R B is minus and green will increase, either R is increases and green B is minus. So these are the three chances of converting the chameleons. But what is the result? If you see the input, so there a value of the R is 13, value of the green is 15. So 13 minus 5 minus 2. Value of the green and value of the blue is 15 minus 7 minus 2. Value of the B and value of the R is 17 minus 3, 4. So no two colors different in number by multiplication of 3, because we cannot match the, we cannot convert all the, therefore all the chameleons cannot be changed into a single color because there was no uniformity in the numbers of chameleons. So if you make it pair, for example, 13 plus 15 is equal to 28, but when you try to make pairs, we can make only 13 pairs of green and red, and there should be two green chameleons which live alone and they cannot convert it into blue. Suppose if you try to match green and blue, and you can match only 50 pairs of green and blue chameleons, and 15 chameleons can convert it into red, remaining two of from blue remains blue and they cannot convert it into red in this case. So this is how we cannot solve the solution, because there was no invariant. Next one is the jar of marbles. The another example for understanding the concept of invariant. So here you are given a understand the question. You are given a jar full of two kinds of marbles, white and black, and asked to play this game. So what is the rule? Randomly select two marbles from the jar. If they are same color, throw them out. It may be black, black, it may be white, white. But put another black marble from your account. So there was, consider there was an unlimited amount of spare marbles available in your hand. So when they are different, but when they are same, throw them out, but put one black marble in the jar. If they are different, place the white one back into the jar and throw the black one. So this is the simple rule. So here you can understand. So this is the jar from which we collect. If we collect two black marbles, if they are same, We want to throw this blue, two black marbles, and put one marble into the jar. If the marbles are different, so black, 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 then what we want to do, if the marbles are different, place the white marble from this pair and throw the black. So if they are same, if they are white and white, then throw this white and put the black marble inside the jar. So what we want to do, we want to know the original number of white and black marbles. What is the kernel of last marble in the jar? The number of white and black marbles are two variables, namely WB. In each iterative statement, B and W change depending on the colors of two marble taken out, either black black, black white, or white white. It is illustrated into this black. So consider there was a two variable and black and white. We don't know how many black marbles and white marbles inside the jar, but each and every time B plus W change is shown in the algorithm, where B apostrophe and W apostrophe are the values of the variables before taking out two marbles. So notice the way W changes. So this is how the W changes. This is the simple 15 steps. So now you can execute this statement. So only one thing you should remember, the rules and the difference between BW and B apostrophe W. B apostrophe and W apostrophe. So B apostrophe and W apostrophe are the values of variables before taking out the marbles. So this is the algorithm. By executing this algorithm, we can find out whether how many the pair of W, the parity of W is invariant. So execute this statement and try to understand the how W is invariant. So next one is recursion. So I already told you recursion is closely related to iteration. It is similar to iteration but more powerful. Using recursion we can solve a problem with a given input by solving the instance of problem with a part. So consider there was a customer or waiting in a queue, and the person who was in counter want to know how many customers are there in the queue. Instead of counting himself, he may ask the first customer to tell what is the length of the line, and first customer will ask the second customer. For example, there are five customers, namely A, B, C, D, E in the queue. The counter person asks A, tell him that how many customers are there. Then A asks B, B asks C, C asks D, and D asks to E. So E replies because he is the last person. After that there was no person in the queue. That's why he replies. He replies there was none of the person behind me. I am one. So he replies one. And D accept this one, and D replies to C that I am one before one. So 1 plus 1 is equal to 2. So 2 is the output from D. C is the one who adds with this output and send this output as an input to B. So 3 is the input from for B, and again the B reply to A and tell that 4 plus 1 is equal to 5. If the A replies that 4 plus 1 is equal to 5. So 4 is the input which accepts which was accepted by A from B. 3 is the input accepted from C. 2 is the input accepted from D. 1 is the input accepted from E. So this is the input series. If you take from right direction, then 1 is the output of E, 2 is the output of D, 3 is the output of C, 4 is the output of P. It means where a smaller solutions are calculated. So each and every time a smaller inputs are accepted and they transfer to another problem and try to find out the big solution. So this is how we count the length. This is called the recursion. So here the same recursion process is explained again. So here we tell each and every person in the queue as a solver. What solvers do? Receives an input, passes an input of reduced size to the subsolver. So first solver who receives the input and send the input in the reduced form to the subsolver. So in the third step, receive the solution to the reduced input from the producer, the solution for the given input. So this is how the solver E, D, E, F, C, A, B, C, D solvers accept each and every input from previous solvers and try to create a big solution from the smaller inputs. So the recursive process can be solved through the uh, through basic cases. One is base case, another one is recursion statement. So when this process of recursion will execute, when when it does not execute. So if they consider if there was only one person in the queue, then the recursion process is not going to execute because the problem is single, a small amount. That's why counter person can easily calculate the number of persons in the queue or number of customers in the queue. But when the number of customers are more, the problem size is not small enough, then the recursion process starts. This is the two cases. One is base case where the problem size is small enough. That means even counter person can able to directly solve that problem without accessing the other solvers. So second step is the problem size is not small, so deconstruct the problem into sub problem. So the counter person cannot unable to find out the length of the queue, so he deconstruct the small problem into smaller and ask the first person to tell him what is the length. The first person as second, the second as to third, third will ask to fourth. In this way, asking the question of lengthing from first person to second, second to third, and from third to fourth, all this process execute till the last person's yeah, that is nth person. So from nth person we get the output, a small output, and by accessing the small inputs and accumulating the input and producing the new output and sending the output to the next person. So in this way we get the solution. So this is called the recursion process. Another important example for find outing the recursion or identifying the power of recursion is, so designing a recursion algorithm computing a power of n. We construct an iterative algorithm. Here power of a comma n, input n is an integer. If n should be greater than or is equal to 0, output is a power of n. So what is the two step? One is base. Base will execute when n is equal to 0. So if the value of the n is equal to 0, then any number of power is equal to 0 is 1. So simply we get the output 1. If the value is not equal to 0, then else part, that is recursion statement will execute where a into power of a comma n minus 1. That is the same algorithm is called here. The same function is called here. So here you can see the algorithm declaration. For example, if the value of n is equal to 0, then we get the output directly 1. If the value of the n is 5, then what will happen? See, the n will reduce to 4 because each and every time n value is reduced and try to find out the power of a power. So again value of the n is reduced to 3, again value of the n is reduced to 2, again value of the n is reduced to 1, again value of the n is reduced to 0. After that we cannot reduce, so value of the, when the value of the n is 0, then output is 1. So again we get the output 1. So value of the n is incremented by 1. Here we get the second step, we find out the 2 power of 1 is equal to 2. In the second step, when the value is incremented, 2 into 2 is 4. So again 2 into 4 is 8, 2 into 8 is 16, 2 into 16 is 32. This is how we decrease the input sizes from bigger to smaller and increase the solution size from smaller to bigger and find out the big solution from doing small works. So this is called the recursion. The next one is the recursion process. Consider there was a corner covered board. It is a board of 2 power n and 2 power n squares in which the square at one corner is covered. So this is the square where a single corner is covered with a single square tile. A triominos, this is the shape triominos, L-shaped tile formed with three adjacent. So here you can see three adjacent squares cover the corner board with the L-shaped triominoes without overlap the. So we want to cover these triominoes and form the cover for each and every square's last tile into triominoes. So we place these triominoes in the center of the board and we cover the we convert this board into smaller boards and we cover the three tiles with the cover with the triminous cover. So this tile is converted into four parts and four parts adjacent are covered with the small tiles. Again we place the triminous in the center of each square boards. See, in each square boards we place the triminous. Again we split this bigger square board into smaller square boards and finally we get all the square boards corners are covered. See, so this is how we solve the covering the square board corners single tile with cover. So here we can see the algorithm for covering the square board with the triominoes. So I hope you understand the concept of invariant and recursion. This is the last topic of this lesson. I hope you understand. If you have any doubt, contact me through WhatsApp. Prepare the question and answers for the book back exercise. Send the assignment to my WhatsApp number. Prepare well for examination. Best of luck. Thank you. Assalamu alaikum.